Welcome to the third talk for this afternoon. Our next speaker is Evan Kohilas, who will be speaking about When the Python Bites, a survival guide to errors. I must nitpick one thing in the title. Pythons are actually non-venomous and they don't bite.
Yes.
But biology aside, Evan is a third-year computer science and math student at the University of New South Wales. And he enjoys tutoring Python to high school students through the National Computer Science School and the NCSS Challenge as well. Evan, take it away.
Cool. Thank you. So having tutored lots of Python and programming, errors have always been an issue. So what are they? Well, errors are Errors are to signal when something has gone horribly wrong. And so we have a couple of different types of ways that things can go wrong when we're programming Python. One of those ways is when we can get errors from bad syntax. So for example, you get a syntax error when Python can't read your code. And in this case, we've forgotten a brace. This would be similar to us writing lots of paragraphs without putting any full stops. It would be very hard for us to understand how to read that, because that's not how grammar works. Another way we can get an error is from bad logic. And so in this case, we have a function that tries to take the midpoint of A and B. And what we want to do is we want to add A and B and divide them. But what we've actually done is we've forgotten the brackets. And now we're dividing B by 2 and then adding them, because that's how maths operations work. If we run this, we get 20 instead of 15. Another way we can get an error is through runtime. And runtime errors happen when something unexpected has occurred while your programming is running. So an example of this is we have this inverse function, and we can enter numbers into it, like for example 2, and the inverse of 2 is 0.5, half. But what happens if we put something like 0? Well, we get a division by 0 error, because this is just how maths works, right? And calculators will do the same thing. They don't know how to solve this problem for you. So what's one way of dealing with errors? Well, we could use if statements. We could, for example, check to see if our function takes in a 0, and if it does, we can print out we can return false. Otherwise, we can return true and print out what the reciprocal is. And so in this case, we can put in 1, and we get 1. Or if we put in 0, we'll get a custom print message here that says, error, we can't print the inverse of 0. And what we're also doing is we're saying, OK, try running this function, and if it ran correctly, then print the error message. If it ran correctly, just go on as normal. Otherwise, print an error message. And this is actually how errors are handled in lower level languages like C. And you'll see this kind of code a lot in lower things like operating systems. And this is actually an example. What we have is a function that tries to create lots of objects into a list, and it iterates through the number that we want to create, and creates an object and puts it into that list. And you'll see what it's doing is it's saving the return value as an error. And what we're doing is we're saying, OK, if that error is 0, if it's false, go on as normal. Otherwise, if we get an error, we have to remove all the previous objects that we made. Say, for example, we ran out of memory. We have to clean up after ourselves. And then we also have to tell the person who called us to say, wait a minute, we had an error, so you should probably clean up as well. And this is actually why a lot of the old programming style has things like return 0 and such, because it's saying we have no error. So this is actually really tedious and annoying, right? We don't want to have to catch every single thing we want to do. And this is where exceptions are actually really useful. And in Python, exceptions is just a class. And so what we can do is we can say, OK, if the value is 0, we can just raise a 0 division error. Otherwise, we can print the value and then return true. And you'll see we get an error like this. But now you might be asking, well, what's the point of that? Well, now we don't have to return true and false. Now we can just return the value when it runs correctly or raise an error when it doesn't. Okay, so the other nice thing is we have try except blocks. And with try except blocks, essentially what we're saying is try running this bit of code, and if something bad happens and we expect it to happen, then run this instead. And so now, like before, our inverse function is now as simple as it can get. It just does 1 divided by x. And now what we can do is we can say, OK, try running this bit of code, and if an error happens, print this instead. And so if we run this, and we got 2, it works as normal. But if we put in a 0, we get a problem, right? We just print out the message. But what if, for example, we do something like, whoops, OK, sorry, let's move on. So we can extend this functionality and say, put it in a loop. And now what we can do in the loop is just keep running that loop until we get functionality that works, right? If we keep getting an error, we want to keep asking the user to put in the correct name. So if we run this, we can do something like put in a 0, doesn't work. Put in 2, it works. Or we can even put something like 1.5. But wait, now it doesn't work anymore, right? Because we've got a different error. And what you find is that the problem here is that our try except statement is actually saying, try running this bit of code. If any error happens, catch it, and then do whatever else. And so what we actually want is we want to say, try running this, and if something happens and we expect this specific thing to happen, then run this instead. And so now we can change our code again to say, OK, try running this bit of code. If a 0 division error happens, run this instead. And so now when we run this, say, for example, we put in 0, we get a 0 division error, and it goes again. And if we put in something like 1.0, we get a value error. And the value error is just saying, OK, you gave me a float, but you wanted me to convert it to an int, and I can't do that. And so what we can extend this with, again, is just catch that value error, and we can specify our print message for that specifically. So we can run this and say, OK, 0 will do what we did before, and 1.0 will say 1.0 is not an integer, it's a float. Cool. So why do we want exceptions? Well, with exceptions, we don't need to check or sanitize all our inputs ourselves, right? And this is actually really useful because otherwise we would have to be checking everything ourselves. That didn't make sense. If we check everything ourselves, it'd become really messy, right? And not only that, it would also be very slow. And in this way, instead of having to check and then do, we can just do, and if something bad happens, we just go on. The other thing is we don't have to thoroughly check all possible cases. We don't have to sit there and say, OK, check that the input is a number, and if it is, go on. Check that the input is a 0, and if it is, do this. We can just say, try running this, and if something happens, we can deal with it later. And the other nice thing is that Python's functionality will let us handle all these cases ourselves. The other nice thing is with try except statements, we don't have to rely on other people to get their code right. If we have to rely on them to make sure that they put the correct error messages and the error codes and so forth, we'll have a lot of problems. And finally, exceptions give us a very simple system for propagating errors throughout our program. And so we don't need to return things like error messages to say, hey, clean up after yourself. That person will do that for themselves. So errors are awesome, and how do they work? How do they do this propagating thing? Well, we have this bit of code. Now, stick with me. Main calls level 1 calls level 2 calls level 3, and level 3 calls our code from before. And if you abstract it a bit, this is actually how most of your code will work. So So now when we call main, we can just enter a number like normal, and it will just go through those couple of functions and get to the end. And this is what it would look like. So what if we change the level 2 function, and we say, OK, level 2 should try calling level 3. And if it gets a value error, then print an incorrect value. So now, if we put in something like 1.0, we'll get incorrect value. And what's actually happening here is we're saying level 3 now got a value error, and it's being propagated up to level 2. And in level 2, there's a try except statement, and it catches it for us, which is great. But we also have something like this, right? Let's redefine level 1 to try calling level 2, and if we get a 0 division error, we can catch that as well. So let's run this and put in something like 0, and we get can't take the inverse of 0. And so again, what's actually happening is level 3 runs, it gets a 0 division error, and it goes up to level 2. And it'll go through our try except statement, and it'll say, hold on, I'm not checking for this, keep going, and it'll go up again. And in level 1, we'll try to catch the 0 division error. We'll try running the code, and the 0 division error will appear, and we'll catch it, and then we'll stop right there. And so we can redefine level 3 to do something like square root a number. And so let's put in 2. But now we have a name error. And what's happened here is level 3 does some code, it runs, it has a name error, and it goes all the way up through the couple of functions. None of the try except statements catch them, and then it stops at main. And at main, it doesn't catch it either, so it goes back to us, and we can see it as it was. So now that you have a general understanding of how these errors are passed through a program, you might ask yourself, what do they mean? Well, here's an example of a syntax error. Normally when we get errors, we want to look at the last line. And the last line is the most useful information, sort of. We get a syntax error in this case. On the left, we have syntax error. On the right, we've got what that error was. And above that, we'll have a line of code. And in syntax errors, we even get a helpful arrow that says where this error was. And so in this case, we'll try importing. We run import from. And Python, as it's reading, it will say, hold on a minute. From doesn't come after import. It needs something else instead. And so it'll stop and say, I can't read this anymore. And then again, above, we've got the file that this bit of code was running in and the line that the code was in that file. Another thing we can have is a traceback. And in a traceback, essentially, it's us running through lots of different functions. And it's trying to trace where our code was running. And so at the bottom, you get the error. And then, right above, you get your line of code. And then that line of code will be in that file at this line inside this function. And above that, you'll see how that function was called, where that line was, and in what module or other function it was. So there are a lot of errors in Python. And I kind of wanted to show you all of them, but there's a lot, so I won't do that. But the general idea is that we have all these exceptions that are children of other ones. So for example, we have a base exception, which is like the overarching godfather. And then we have all these errors underneath. So for example, we have an exception and a keyboard interrupt. And then arithmetic error will come from exception, and inside it will contain 0 division error. And again, we have a lot of other errors as well, like lookup error, name error, recursion error, syntax errors, and so forth. And the point I'm trying to make is that all these are children of errors from before. So now that you kind of know a bit about errors, let's do some debugging. So all the following snippets of code will produce syntax errors. And I'll be asking you why. So here, why does this code produce a syntax error? Yeah, right? It's very simple and visible to us. We've just misspelled on. And Python will even tell us that. The arrow is pointing to on and saying, this word doesn't look right. What about here, right? If we run this, the arrow will go up to true, but that doesn't even make sense to us because an experienced programmer will look at that and say, okay, you've misspelled that keyword. But a beginner will look at that and say, true looks fine there. I don't know what's wrong with while. And what's actually happening is Python will read the while keyword as an actual variable, and then we'll read true and say, hold on, true doesn't follow variables in that way. I don't understand this anymore. I'm going to crash. What about this? Yeah, we're missing a quote, right? And again, Python will try and explain this to us and say, I've read all the way to the end of the import, and I haven't seen a quote. It's like us forgetting the full stops again. And again, a code like this will get a missing semicolon, a missing colon rather. And the arrow will point to the end of the line and say, well, a colon is meant to be here, but I don't see one. What about this case? Yeah, right. That's really easy for you to pick up. And for Python, it will read to the end and say, OK, I'm expecting something here, but I didn't see anything. But if we look at something like this, and we actually run it, Python will point us to the end of here. And it should be a very simple error, right? It should just point here and say, you meant to put a brace. I don't have one here. But what's actually happening is Python is reading this line of code as a list comprehension. And as soon as it reads a semicolon, it says, hold on, I was expecting a bracket to close that semicolon, that list comprehension, but it wasn't there. So moving on from syntax errors, we have this code. And this is actually a bit of code that a lot of people will come upon sometime in their programming experience. And the first time you come upon it, it's very unclear what's happening. So does anyone want to take a guess?
Your module random, the custom module random is overridden system random.
Yeah. So the way import works is it will try to import from our current directory first. And in the current directory, it finds a file called random. And it'll import itself, essentially, and it can't find the shuffle defined in itself. And so when you try and call shuffle, it says, OK, I don't see shuffle. It doesn't exist. OK, here's another one, right? What do you think this might be? Missing brace? Index error, right? Initially, it looks fine, right? But when we actually run this code, we get a logic error, which is it's going out of range. And so what's happening is we're printing 0, and we're printing the index of 0. Then we're printing 1, and then what is at index 1, and then 2, and what's at index 2. And then finally, we're printing 3. And we try and index 3, but we can't get anything out of it. And so we can't get anything out of it. And so Python says, hold on, I can't index this anymore. Here's an example of a key error. If we run this and put in Ashley, Ashley isn't a key in the dictionary, and it'll just tell us very simply, this is a key error. What about this? Recursion error, right? We've forgotten the base case. And so Python will just keep running the same bit of code over and over again until it reaches the maximum recursion depth. And essentially, it's just trying to tell you, you've missed the base case here, which can be really helpful if you're learning recursion. But what about something like this? We might want to try running this with 10 and say, I want to add the numbers from 1 to 10, and we get 55. But if we try and instead add the numbers from 1 to 1001, we'll get another recursion error. The base case is there this time, but what's actually happened is Python will limit the amount of recursions you can make in order to help you catch yourself in the situations where you might make a mistake. And if you do get this, and you really need to, you can actually change what that recursion depth can be. Okay. A value error in this case is just when you try to do something with a value that doesn't make sense. And so, for example, if we put in something like 1, or let's put like hello, it doesn't make sense to try and convert hello into an int, right? And it would never make sense. Type error is like the opposite of that. It's like saying it doesn't make sense to do something with this type. And so if we put in 10 and 10, we're trying to add the number 10 and the string 10, but it doesn't make sense in Python to add strings and ints together. Here's another error. I didn't actually know what this might be. Who else could have a guess? So yes, range won't take 4 arguments, but what we'll actually get is a type error. And this is one of those cases where it's just like, okay, it doesn't really make sense what you're trying to do here. There might be some reasoning behind it, but essentially we're just trying to say there's too many arguments. What about this case? Yep. So what we're trying to do is we have a list of numbers, we sort them, and then we want to reverse them. And then we want to just get the second number in that list. But reversed isn't a list. It doesn't give us back a list. It gives us back an object. And that object doesn't have a way to index into it. And so we get a type error because we're using that type in the wrong way. And finally, we have what we saw before, zero division error. And again, this is another way of getting a logic error. We think that this code will work as expected. For example, we can put in the average of 1, 2, 3, and we get 2. But if we run this, and we, for example, don't put any numbers in, well, Python will do what you told it to. The length of an empty list is 0, and now we're trying to divide by 0, and so it breaks. So errors are great, but how do you really make the most of them? Well, you can make your own exceptions. And remember, exceptions are just a class. So you have an exception, and it will become a child of another exception that you want to be. And we don't need to put anything down here, but it's nice to put in a string to just say, or a comment to just say, this is what this function does, or this is what this error does. But why would we want to make our own exceptions? Can't I just use the ones already there? Well, they're actually very helpful. Take this case where we have a scanner, and this scanner code will take a hardware scanner, read from it, and keep reading from it until it finds something that is valid. And the valid function will just check if they're all digits. But this might have errors, right? What if the scanner disconnects while we're reading from it, and we try and read from it, and there's an error? Our code will just crash, and anyone who's trying to use that scanner or that scanner app, it just won't work for them. And so what we can do is we can define our own scanner errors and an invalid barcode error. And now what we can say is we can try running the scanning code, try running the reading code, and if we get an error, we can just rephrase that as a scanning error. And so now, when something happens, we can expect a scanner error to happen, and if it does, we can just restart the scanner. And again, with the read barcode, we can read a barcode and validate it, but if it's wrong, we can raise it as an error. And it's useful to raise it as an error because we might have a problem where we've made a mistake and we want to keep track of all the errors that we've made. But errors won't catch everything. Exceptions, again, won't catch all the logic errors we've made. And so we've actually made a mistake. We've assumed that barcodes are all made of digits. But in fact, they're made of digits and letters. And so what we really want is to change this. But the nice thing about having errors is that we can catch them later on. And finally, the other nice thing about making your own errors is that later on, when someone else goes to use your code, they can catch that specific error as well, instead of having that problem that we had earlier. Awesome. Thank you.
Alrighty, thank you very much, Evan. We have time for a few questions.
Thank you for the talk. Could you explain what the differences are between the errors and the exceptions?
Right. So errors are, in Python it's a bit different, but errors are kind of the overarching term for when something goes wrong. And exceptions are the way that we handle when something goes wrong in Python. And so we can explicitly say, catch something that might be exceptional, and then deal with it later on. Does that make sense? OK, cool.
Thanks, Evan. Great talk. So if I'm creating my own exceptions, how do I know what I should inherit from? Should I always just inherit from exception? Or how can I tell if maybe this is a type of value error or a type of type error? You know, those kind of things.
Yeah, that's a good question. I guess it is kind of up to personal preference, but also it would be something that you would have to consider in terms of what your code is actually doing. So if you get a key error, then it's nice to wrap that around and specify exactly what your key error is with by just inheriting from key error. Generally, you want to inherit from runtime error, I would think, because those are errors that would happen during the runtime of your program. And so that scanning example was actually a real-life example. And they were just returning runtime errors everywhere that they had a problem. Because it didn't make sense to use key error or index error or anything like that, because that wasn't the error. The error was that there was something wrong with the runtime. But then that was a problem for me, because when I was trying to catch those errors and deal with them appropriately, the only thing I could catch was a runtime error. And anything that they had as an error was a runtime error. And so the main thing you want to get out of it is just specifying exactly what it is so you can deal with it specifically. Cool.
Any further questions? Still have a few minutes. No, well, in that case, let's thank Evan again. And I have an official PyCon mug for you
Thank
with
you
a
very
cat.
much. Awesome, thank you.